The last type of problem we'll have in section 7.6 works with word problems. So it says the Mississippi River has a current of 3 miles per hour. A boat takes as long to go 8 miles downstream as to go 6 miles upstream. And then it says, what is the speed of the boat in still water? So in order to do this, we have one really important formula that we need to know, and that is D equals RT, where D stands for distance, R stands for rate, which is also a speed, and T, you guessed it, stands for time. Distance, it depends on the problem. In this case, our distance, it talks about being in miles, so our distance is in miles. Our rate or speed when we're using miles is normally miles per hour. So that's what we'll use for that. And if our speed is in miles per hour, then our time has to be in hours. So what I'm going to do is I'm going to set up two different pieces of information. Two different sort of data sets. One is of the boat going downstream, and the other one is the boat going upstream. And I'm just going to abbreviate that using D for downstream and U for upstream. Oh, DS downstream, US upstream. There we go. Okay. So the one thing we know about this is that it says the boat takes as long to go 8 miles downstream as to go 6 miles upstream. So that means that the time for both of these is going to be the same, right? We don't know how long it is, but we know it's going to be the same, so we're going to use the same variable. The next thing we know is that when it goes downstream, the distance is 8 miles. So this is our time, Our distance when it's going downstream is 8 miles, whereas our distance when it's going upstream is 6 miles. And then the last thing we're looking for here, right, we have D and we have T. We're looking for our rate or our speed. Now, we're wondering what is the speed of the boat in still water. So we're wondering that. We don't know what that speed is, but we do know when it's going downstream, it has the current helping it. So for speed, I'm going to use S just because that's kind of an easy variable to use for speed, right? So I know that when I'm going downstream, I have whatever the boat's speed is plus the current is working with it. So that makes it go faster. Whereas when the boat is going upstream, it's taking away the speed from the boat. So we're saying S plus 3 and S minus 3. Now, like we went over in the last example, we know that we're able to solve for different variables in a formula. Like in this case, D equals RT, we're solved for our distance. Well, our distance is different in these, but what's the same? The time is the same. So my first thing is I'm going to take D equals RT, and I want to solve for T because that's what they have the same. That's what's in common. So in order to do that, I'm going to divide both sides by R to get T equals D over R. And I'm going to set up an equation for each one of these. So for our downstream, we have T equals 8 over S plus 3. And for upstream, we have T equals 6 over S minus 3. And since they're the same, right, they have the same variable, that means that basically 8 over S plus 3 and 6 over S minus 3, they equal the same thing. Or in other words, they can equal each other. And that's how we're going to do this problem. We're going to take that information that we have and we're going to set them equal to each other. 8 over S plus 3 equals 6 over S minus 3. And as we learned, well actually we haven't learned it yet, but well, no, I take that back. As we learned in section 7.5, in order to work with these fractions, we would go ahead and get both denominators to be the same. So when we look at this, each denominator is completely factored. They have no factors in common, so that means we need to multiply the denominators by each other to get a common denominator. S minus 3, whatever we do to the bottom, we're going to do to the top. Here, S plus 3, and again, whatever we do to the bottom, we do to the top. That's a little mess up, and I don't have any white out. Rewrite the fractions so that they have the same denominators. 8 times S minus 3 over S plus 3, S minus 3 equals 6 times S plus 3 over S plus 3, S minus 3. Now that we have our common denominators, we can ignore our denominators and simply solve using our numerators. So I'm going to distribute my 8 in here, my 6 in there. I'm going to draw a lot of arrows here. I'm running out of space on my paper. 8s minus 24 equals 6s plus 18. Move all of our s's to one side. At the same time, I'm going to move all of our constant numbers to the other side. So we have 2s equals 20, 30, 42. And then finish solving by dividing both sides by 2. And s equals 21. Now, writing a solution like s equals 21 means absolutely nothing. Hey guys, what is the speed of the boat in still water? S equals 21. That means nothing. So I always say if you start with words, you should end with words. What is the speed of the boat in still water? The speed of the boat in still water is 21 miles per hour.